A linear function graphs a straight line. The parent function, remember, is f of x equals x. In order to graph them, it's kind of a two-step process. The first step is to plot your y-intercept. Which is the b value when you're looking at y equals mx plus b. B is your y-intercept. The second step is from that point that you just plotted, you count whatever your slope is, and remember, slope you count as a rise over run, and you make a second point. So you count from your b value. So for this first example, it's asking us to graph f of x equals negative 1/3 x. So the first thing that's a little bit strange is that there's no b value. There's no plus or minus a number. So what you can do to make that look a little bit better is you could add a plus 0. It doesn't change anything, but now you can actually see the b value. So we want two things. I want to identify the slope of the line, and I want to identify the y-intercept. So the slope of this line is negative 1/3, and the y-intercept, as we just talked about, is 0. So here's how this works. I'm going to take my y-intercept, which is 0, and I'm going to plot on the y-axis. I'm going to put a point at 0. Now from my point, I'm going to use my slope, and I'm going to go down 1 and right 3. So that's where my purple point ends up. Now that negative can either go with the 1 and make you go down 1, and then your 3 would be positive. So let me write this down. You could either do down 1 and right 3, or you can go up 1 and left 3. As long as one of your values is positive and one is negative, that's really all that matters. So I could have gone up 1 and left 3, and all of those points should line up to make your line. So here is my first line. All right, now we need to identify domain, range, and end behavior, which we did in lesson 3.1. So for the domain, if I extended this line forever and ever, it would go all the way to the left, all the way to the right. So the domain would be all real numbers. And the range will be the same. If I extended the line, it will go all the way up and all the way down. So the range is also all real numbers. And that is actually going to be true of every single line. Everything in the linear family, the domain and the range will always be all real numbers. All right, end behavior. Remember that it always starts the same way. X is going to infinity, x is going to negative infinity. So I'm going to imagine myself on a roller coaster on the line. If I followed this line to the right, I would also be going down. So that means that as x goes to infinity, y will go to negative infinity because the values are getting lower. If I follow the roller coaster follows the line to the left, my y values will be going up. So that means that as x goes to negative infinity, y goes to positive infinity. For example 2, I need to identify my slope and y-intercept. My y-intercept is the easy one now. It's negative 3. And the slope you can't actually see, but what that means is that there's an invisible 1 here. So you could say that the slope equals 1. And if you wanted to write it so that it's a fraction, you could write it as 1 over 1. That way you can see the rise over run. So now I'm going to plot my y-intercept, which is negative 3. So on the y-axis, which is the vertical one, by the way, on the y-axis I'm going to go to negative 3 and I'm going to put a point. And now from there, I'm going to use my slope. So since they're both positive, I'm going to go up 1 and right 1 and put a point. Kind of like what we talked about before, 1 over 1 is the same as negative 1 over negative 1 because the negatives would cancel each other out. So I could also go down 1 and left 1, and that would also give me a point on my line. You only need 2 points, though, to be able to draw your line. All right, so for domain, we just talked about how domain and range actually are always going to be all real numbers when you're talking about something that's in the linear family. The end behavior, as x goes to infinity or to the right, if I put my little roller coaster car here, if I'm going to the right, I'm also going to be going up. So that means as x goes to infinity, y also goes to infinity. If I followed the line to the left, my values would be going down. So that means as x goes to a negative infinity, y also goes to negative infinity. Transformation of functions are ways that a function differs from a parent function. So the different transformations that we could talk about. So for example, we're going to talk about translations, reflections, and dilations. So information specific to linear functions. The only two things that can change are the slope and the y-intercept. So when the slope changes, there's really only three things that could happen. You can have a slope that is less than 1. So I'm talking about like 1/2 or 2/3. So that would be like a fraction that would turn into a decimal that would be less than 1. If that happens, your line is going to be flat, or sometimes we use the word shallow. If your slope is greater than 1, it's going to make the line steeper. And when I'm talking about flatter and steeper, I'm always comparing to the parent function. And the parent function looks like this, where it's just a line that goes like straight through the middle of the first and third quadrants. So this is the parent function, f of x equals x. So if you were looking at, if your slope was less than 1, it would look something like this, where it would be flatter. So that would be if your m is less than 1. If your m is greater than 1, it would be steeper. So it would be something like this. So if you could imagine yourself walking on a line, if you were walking on the yellow line, it would not be so hard. It's like getting to be almost flat ground. If you were walking on the light blue line, it would be really hard to climb up because it would be so steep. If m is negative, what it's going to do is it's going to take the green line and it's going to make it a decreasing line. So right now, if you were to start walking right here, where I just put this orange star, if you were to walk, you'd be going up towards positive infinity for your y values. If I reflected it, it would look like this. So it's the exact opposite. So now if you were to start up here, you'd be walking, it would be decreasing in value. So I like to use the word reflection because that makes the most sense to me. But it would turn into a decreasing line. The y-intercept can also change what your line looks like. If you have a plus b, so that means your, for example, like y equals 5x plus 7. So your b value is being added. It's going to shift your graph up. And by shift, what I'm really talking about is a translation. So you could also say it's going to translate up. If you have a negative b, so another example would be like y equals 2/3 x minus 1. So if you have a negative b value, it's going to shift or translate your line down. So in these examples, we're going to just describe the transformations. So remember that there are three things that could happen. Your line could become steeper or flatter, it could be reflected, and it could be shifted up or down, depending on your b value. So let's take a look at number 1. The only thing that is different is this 7 right here. And remember that if you have a slope that's greater than 1, it's going to make your line steeper. So that's all you have to say, is that it's going to make the line steeper. And you could even say steeper by 7 or 7 times steeper. But that's all we have to do. For problem number 2, the slope value is not different. And what I mean by that, again, is I'm always comparing to the parent function. The parent function has a slope of 1, and this graph has a slope of 1. So I'm not worried about, it's not going to be steeper or flatter. There is a negative though, and that negative will reflect this line. So I'm going to write reflection, and then this plus 4 is also going to translate my graph. It's going to shift everything up 4. So all you have to write is up 4. And then the last one, there's a lot going on here. I see that it has a negative. So right away I can tell that's going to be a reflection. My m value is 1/2, which is less than 1. So that means this is going to be flatter. It's going to be flatter than what the parent graph looks like. And you could say flatter by 1/2. And then I also have this 3 here, which is a positive number, so it's going to shift my graph up 3. Given the function f of x equals negative 2/3 x plus 4, we're trying to graph, describe the transformations, and list the domain, range, and end behavior. So kind of everything that we've learned all smushed into one problem. So the first thing we're going to do is transformations, which is what we just finished doing on the previous slide. So I noticed that there's a negative here. So since there's a negative, I know that this is going to be reflected. I also see an m value of 2/3, which is less than 1. By the way, you can tell that a fraction is less than 1 if the numerator is smaller than the denominator. So I'm going to make a note here. A fraction is less than 1 if the numerator is smaller than the denominator. Okay, so since 2 is smaller than 3, I know this fraction is less than 1. So that means that this is going to be flatter. And you could say flatter by 2/3. Flatter is good enough. And then I see a plus 4, so I know this is going to be shifted up 4. So what I'm going to do here before we graph is I like to have the parent function on here, and I'm going to put the parent function in gray. So the parent function looks like this. And that way when we graph our new one, you'll be able to see what transformations actually happen. Okay, so let's actually graph. So we need the slope and the y-intercept. Slope is negative 2/3. Y-intercept is 4. So I'm going to go up 4 on the y-axis, and then I'm going to use my slope. I'm going to go down to right 3. So down to right 3 would be here. And then I'm going to connect the dots. So now you can see, compared to the gray line, you can see it's reflected. It's decreasing instead of increasing. It's a little hard to see, but it is a little bit flatter than the gray line. And then you can see also that instead of crossing through at 0, 0, now it crosses through at 4. So you can actually see all these transformations. As we talked about, the domain and range of a line will always be all real numbers. And then for the end behavior, we can set up our answer because we know they all start the same way. So if I was on the blue line, and I was going to the right, my y values would be getting smaller. They'd be getting lower. So that means my y value would go towards negative infinity. If I was on the roller coaster going towards the left side of the graph, the line would be taking me up. So that means that my y values would be going towards positive infinity.